mean and variance of binomial excuse me, mean and variance of binomial distribution are 4 and 4 by 3. Then find p of x greater than or equal to 1. So we know that mean and variance of binomial distribution. We know that in binomial distribution, mean is NP, variance is NPQ. So now what is given? Given mean equal to mean NP equal to 4, variance NPQ equal to 4 by 3. Now we need to calculate P and Q so that we can calculate probabilities. To find probabilities in binomial distribution, we use probability of R success formula, NCR P power R Q power N minus R. So to find any probability in binomial distribution, we need to calculate 3 parameters, N, P, Q. That's why binomial distribution, we will write in binomial probability of R success formula is NCR P power R Q power N minus R. So to find probability of R success, we use this formula. So for that we have to evaluate NPQ values. Now what I am doing, I am finding NPQ by NP value. So that NP get cancelled, we will get Q value, right? NPQ is 4 by 3 by 4. So here NP get cancelled, 4 get cancelled, Q is 1 by 3. If you know Q, we all know that P is 1 minus Q. In binomial distribution, P plus Q is 1. That is the reason. That's why P is 1 minus Q. Then what is P? P equal to 1 minus 1 by 3. 3 minus 1, 2 by 3. Now we know P value and Q value, we need N. So from NP equal to 4, you can easily calculate N. What is P? 2 by 3. N into 2 by 3 equal to 4. N equal to 4 into 3 by 2. If we send 2 by 3 to that side, that becomes 3 by 2. So 2 1s are 2 2s are 2 3s are 6. Now we have N value and also Q value and also P is 2 by 3, P value. We have NPQ values, so we can calculate probability of x greater than or equal to 1 value. So probability of x greater than or equal to 1 means we will do in 2 cases. Number 1, greater than or equal to 1 cases, starting from 1 to 6. Probability of 1 plus probability of 2 plus probability of 3 plus probability of 4 plus probability of 5 plus probability of 6. But you need to write that NCR P power R Q power N minus R formula 6 times. You have to substitute all the values. The calculation may be little bit lengthy and difficult, time taking. There, to reduce time and to calculate very easily, there is one indirect method. P of x greater than or equal to 1 can be written as 1 minus P of this greater than or equal to becomes less than. If you have equal to here, don't write equal to. If you don't have equal to here, write equal to. What I am saying, if you have here P of x greater than 1 only, then you will get here P of x less than or equal to 1. We are having here equal to, so don't write equal to that, so that you will get P of x equal to 0 case only. X less than 1 means P of x equal to 0, P of 0 case. P of 0 means NCR, that means 6C0 P power R 2 by 3 whole power 0 Q power n minus R 6 minus 0. NCR P power R Q power n minus R. So what you will have finally, we all know that NC0 is 1 and anything power 0 also 1. So NC0 1 means 6C0 also 1. Then 1 minus 1 by 3 whole power 6. If you calculate that value using your calculator, you will get the final answer 0.9986. This is a probability, it should lies between 0 and 1. So value should be less than 1. 0.99 probability of x greater than or equal to 1. Any doubts you may express here, anywhere. 10 coins are tossed simultaneously, find the probability of getting at least 7 heads. This is the exact case where the binomial distribution use we know very well. The use of binomial distribution we can understand very clearly by solving this problem. So in general way, if 10 coins are tossed, imagine what is n of s? 1024, 2 power 10. If you write 1024 outcomes, from that you can select the number of heads are 7. At least 7 heads means 7 heads case, 8 heads, 9 heads, 10 heads. You need to pick from 1024. How difficult it is, you imagine once. That type of big difficult problem by solving in classical method, we are going to solve that one using binomial in a minute. Very easily. In very less time compared to that. See how. Here the number of coins tossed are 10. So n is 10 coins. For one coin, we will calculate probability of success, getting head. For one coin, P is probability of getting head. Probability of getting head, which is 1 by 2. Q is probability of getting tail. Failure case. So that is also 1 by 2. We know n, p, q values, then we can easily find out probability of getting at least 7 heads. Probability of getting at least 7 heads. At least 7 heads means minimum 7, maximum as many as possible. That means up to 10. What I am saying? At least 7 means greater than or equal to 7. Maximum 7 or at most 7 means less than or equal to 7. This point you need to keep in your mind. Minimum 7, maximum as many as possible. Now P of x greater than or equal to 7 means up to n, starting from 7. P of x equal to 7 plus P of x equal to 8 plus P of x equal to 9 plus P of x equal to 10. These all we need to calculate. So we know in binomial distribution, for P of x equal to r, we have one formula, NCR P power r Q power n minus r. in binomial distribution. So using that formula, by substituting NPQR values, 10C7P 1 by 2 whole power 7 Q 1 by 2 whole power 10 minus 7 10 minus 7 3 10 minus 7 plus 10C8 1 by 2 whole power 8 1 by 2 10 minus 8 2 10C9 1 by 2 whole power 9 1 by 2 whole power 10 minus 9 1 10C10 1 by 2 whole power 10 another one 1 by 2 whole power 10 minus 10 1 by 2 whole power 0 1. So if you observe here, the powers 1 by 2 same, bases are equal. You can add exponents. 7 plus 3 10, 8 plus 2 10, 9 plus 1 10, 10. That means in every term you are having 1 by 2 power 10 in every term. That I am taking common. So if you take these terms common, what happens? You will have 10C7, 10C8, 10C9, the leftover term after common. These are. We all know these values can be calculated using your calculator NCR. By pressing NCR, 10, NCR 7, you will get. Or another way of solving, I said 10C7 means 10 minus 7. 10 minus 7, 3. So, write from 10 to 3 terms, decreasing 1, 1, write 3 terms in product in numerator. Like this, 10, 9, 8. In denominator from 7 or from 3. So, 10C7 equal to 10C3. NCR equal to NCN minus R. Using that, 10C7 is 10C 10 minus 7, 10C3 technique. This technique I used. So if you use the technique, you will get the value. 2 1 ja, 2 5 ja, 3 1 ja, 3 9 ja, 3 3 ja, 5 3 ja 15, 15 8s 120. Like that you can calculate all the values. Or use your calculator. 120, 10C7, 10C8, like that if you calculate 10C2 value 45, 10, 1. 10C9 is 10C1, 10C1 is 10, NCN 1, NCN 1, NCN 1, NC1N. So 10C9 is 10C1, 10C10 minus 9. So if you add all these cases, 125, 130, 130 plus 45, 175, 176. So 176 by 2 power 10, 1024. So this is the case. Just now I said, if you do practically, manually, by calculating these 1024 outcomes, if you pick up from 1024, 7 heads case, 8 heads, 9 heads, 10 heads, how many you will get? 176 you will get like this. Generally, if you write 1024 items, how difficult to pick up 176 items? Here, very easy. Now, if you calculate using your calculator, 176 by 1024, 0.1718. This is the probability of getting at least 7 heads. Any doubts you may express. Determine the probability of getting 9 exactly twice in 3 throws with a pair of dice. How many times the dice are thrown? That is n. The number of times die throws is 3 throws. N equal to 3. Now the P is probability of getting 9. Probability of getting 9 when pair of dice are thrown. So this we can easily calculate. When pair of dice are thrown, n of s for this case is 6 square, that is 36. That means in denominator we will get 36. Coming to favorable cases, getting some 9. When 2 dice are thrown, if you pair 1 to 6 to 1 to 6, what are the cases you are getting some 9? 1 6 you won't get, 2 6 you won't get, 3 6 9. So favorable cases for 9 is 3 6, 4 5 9, 5 4 9, 6 3. Total how many cases? 1 2 3 4. 4. So if you cancel 4 9s are 36. So P is 1 by 9. What about Q? We all know that Q is 1 minus P. So 1 minus P means 1 minus 1 by 9. 9 minus 1, 8. 8 by 9. Q. Now we need to find, determine the probability of getting 9 exactly twice, 2 times. When 3 throws, in 3 throws. So here R is 2. R value is 2. Probability of 2 successes. So in binomial distribution we all know, in binomial probability of R successes has formula NCR P power R Q power n minus R. So using this formula, probability of 2 successes we need. N we have 3, C 2. P we know 1 by 9 whole square. Q also we know 8 by 9, 3 minus 2, 1. 3 minus 2, 1. 3C2 is 3C1 only, 3C1 is 3. 3C, 3 minus 2. NC1 N, 3C1, 3. 3C2 also 3C1. 1 by 9 square, we can write like 1 by 81 into 8 by 9. If you calculate, here you can cancel 3 1s are 3 3s are. So 8 by 243. 8 by 243. Probability of getting 9 exactly twice in 3 throws. If you calculate 8 by 243 using your calci, you will get approximately 0.0329 is the probability of getting 9 exactly twice in 3 throws. Okay. In 8 throws of a dice, 5 or 6 considered as success. Find the mean number of successes and SD. SD means standard deviation. Standard deviation is square root of variance. Variance is sigma square, SD is sigma. So we know in binomial distribution, mean NP and variance NPQ. So here N is given. Clearly N is given. N is 8 throws. P is probability of getting 5 or 6. 5 or 6 when a die is thrown. When one die is thrown, what is the probability of getting 5 or 6 for one die? The total number of cases are 6. Getting 5 or 6 are only 2. 2 by 6. 2 are favorable, total 6. 2 1s are 2 3s are. P is 1 by 3. What is Q? 1 minus P. 1 minus 1 by 3. 2 by 3. Now we have P and Q. we can easily calculate mean and variance. In binomial distribution, in binomial, mean we know. What is mean? Mean is NP. Variance is NPQ. Variance means sigma square is NPQ. Here we need SD. SD means standard deviation, which is root NPQ. So now coming to NP. What is N? N is 8. P value we have 1 by 3. 8 by 3 is mean number of successes. Expectation of X. Coming to variance, N is 8. P is 1 by 3. Q is 2 by 3. So what you will get? 8 2 is 16. 16 by 9. Now SD means root NPQ. Root 16 by 9. Root 16 4. Root 9 3. So like this one can easily calculate mean and variance of binomial distribution when a die is thrown like this. So here we will identify the given distribution is binomial if it is tossing a coin and throwing a die especially. We will consider it as binomial distribution if there are finite number of cases, finite number of trials, finite number of times experiment conducted. If n is small like this, then we go for binomial distribution. Very clear? Any doubts you may ask. Determine mode of binomial distribution for which mean and variance are given. So first, we will discuss about mode very clearly. Before that, we need to calculate NPQ first. We will discuss very clearly what is mode of binomial distribution. First I am writing given in binomial distribution. In binomial distribution, mean we know NP is 4. Variance NPQ is 3. Now NPQ by NP, if you calculate, you will get Q value. What is NPQ? 3. NP 4. So NP get cancelled. Q equal to 3 by 4. Now find out P. What is formula for P? P equal to 1 minus Q. 1 minus 3 by 4. 1 minus 3 by 4 means 4 minus 3. 1 by 4. P is 1 by 4. Q is 3 by 4. Now to calculate N from NP equal to 4. Write in the place of P 1 by 4. N into 1 by 4 equal to 4. N equal to 16. Now we have N, P we have, Q we have. So after evaluating NPQ, calculate N plus 1 into P value. Why I will tell you. What is N? 16 plus 1 into P. P is 1 by 4. So 17 by 4, which you will get approximately 4 point something. 4 4 is 16, right? So 4.25, which is not integer. This is not integer. Why? So now I will tell you what is exact mode of binomial distribution. So mode of binomial distribution is equal to n plus 1 into p, integral part of n plus 1 into p, if n plus 1 into p is not integer. If n plus 1 into p, comma, n plus 1 into p minus 1, when n plus 1 into p is integer. If it is integer, you will have 2. What I am saying, n plus 1 into p is 4, then modes will be 2. 4, 4 minus 1, 4, 3. If n plus 1 into p is not integer like this decimal number, 4 4.25, 3.2, 1.5 like that, then integral part. So that is integral part of 4.25. Here integral part of 4.25 is 4. Integral part of 3.25 is 3. Okay, so the mode of the binomial distribution is 4 for this problem. This you need to keep in your mind. This is the formula to calculate mode. If you get n plus 1 into p, for example, integer like 3 or 4 or 5, if you get 5, 5, 5 minus 1. If you get 4, 4, 4 minus 1. If you get 3, 3, 3 minus 1. So, this is the way of finding mode of binomial distribution. Any doubts you may express anywhere. 2 dice are thrown 5 times. Getting a double is success. Find the probability of success at least once, 2 times. So here, dice are thrown 5 times. Dice are thrown 5 times. That is, n is given 5 times dice were thrown. Here, the success, that is, P is probability of success. Probability of success is here probability of getting double. That means equal number. Here we know for throwing 2 dice, when 2 dice are thrown. For throwing 2 dice, n of s is 36. For 2 dice case, n of s is 6 square, 36. And also favorable cases for double equal numbers are these: 1 1, 2 2, 3 3, 4 4, 5 5, 6 6. These are favorable cases. So we have now favorable cases and also total number of outcomes. We can easily find the probability. Favorable, number of favorable, 1 2 3 4 5 6 by 36, which is 1 by 6. So this is probability of success given. P is 1 by 6. You know what is Q? 1 minus P, 1 minus 1 by 6, 5 by 6. Now in binomial distribution we all know, in binomial, probability of R success formula is NCR P power R Q power n minus R. This is formula for probability of R successes. NCR P power R Q power n minus R. In binomial distribution, to find probability of R successes, we use this formula. Whenever dice case, coin case, when they are thrown finite number of times, tossed finite number of times, that distribution is binomial. Here, die case, that is thrown finite number, 5 number of times, which is small number, not large, then we will treat that one as binomial. So in binomial distribution, probability of R formula is this one. Now what we need to find? The probability of getting double at least once, that is the question first one. Probability of getting double at least once. At least once. That means P of at least minimum once, maximum as many as possible times. So x greater than or equal to 1. I said so many times, at least means greater than or equal to, at most means less than or equal to. So to find a probability of x greater than or equal to 1, starting from 1 up to n, you need to add all the probabilities. Up to n means 5. That is probability of 1 plus probability of 2 plus probability of 3 plus probability of 4 plus probability of 5. Instead of doing that many number of times, adding probabilities, 5 probabilities, applying this formula 5 times. We use indirect case. I said in the previous problem, indirect case means 1 minus total probability minus P of, if you have here greater than or equal to, make it less than. X less than 1 or equal to, if you have, don't keep here equal to. If you don't have equal to here, keep equal to. What I am saying, if you have greater than 1, less than or equal to 1. X less than 1 means only one case, that is P of x equal to 0. In this, write in the place of R0, n value we know, P we know, Q we know. So NCR 5C0 1 by 6 whole power 0, 5 by 6 whole to the power of 5 minus 0. We all know that NC0 is 1 and anything power 0 also 1. So 5C0 value is 1. Similarly, 6 power 0 is 1. So what remaining we are having? 1 minus 5 power 5 by 6 power 5. So this one only we are having. 1 minus 5 power 5 by 6 power 5. 0.59. If you use your calculator, you will get approximately 0.5981 using calculator. Use calci. 1 minus 5 power 5 by 6 power 5. Coming to the second bit, probability of getting double exactly 2 times. That is probability of 2 we need to find. Probability of 2 successes. That means in this formula, write in the place of R 2 in this formula. NCR P power R Q power n minus R. Remaining values you know. 5C2 1 by 6 whole square, 5 by 6, 5 minus 2. So 5C2 means, I said one small technique, 5 into 4 by 2 into 1. 2 1s are 2 2s are 10. By 5 cube by 6 power 5. 6 square you will get 6 cube. Bases are equal, you can add exponents. If you simplify this one, 0.1607, you will get probability of getting exactly 2 times. Use calculator. Okay. Any doubts you may express anywhere? 20% of items produced from a factory are defective. Find the probability that in a sample of 5 chosen at random, none is defective, 1 is defective, probability of 1 less than x less than 4. Here, if you see this problem, first to find out the sample size. Here, the sample of 5. So 5 is a finite value, simple small value, n is small, p is given, probability of defective given, then the distribution is binomial. If n is large, for example, a sample of 100, 150, 1000, 2000 taken, the same problem goes to next distribution, that is Poisson. Very clear how to select the distribution. So after reading the question, find out n, small n. If n is small, so finite value less than 10 or up to 20, you can go for binomial. Beyond that, you can prefer Poisson. And P is given probability of defective, probability of getting defective. Defective item is 20%, which is 20 by 100, 1 by 5. Small p is 1 by 5, q is 1 minus p, 1 minus 1 by 5, 4 by 5. So we know n, p and q. Q is 1 minus p. P plus q is 1 in binomial distribution. And also we know that in binomial distribution, probability of R successes is NCR P power R Q power N minus R. So this is the formula. Probability of R successes. Now the first one is probability of none is defective. Probability of none is defective. That means we need to find probability of X equal to 0. So in this formula, write in the place of R0, NPQ values substitute. N is 5, 5C 0, 1 by 5 whole power 0, 4 by 5 whole to the power of 5 minus 0, 5. We all know that NC0 is 1 and anything power 0 also 1. So finally what you will get 4 power 5 by 5 power 5. So none means, here none means 0 defectives. The name itself says how many defectives we are having. So 0 defectives, that's why we evaluated probability of X equal to 0 by writing in the place of R0 in that formula. You got that value. Use your calculator to get this one. Okay. Coming to the second bit. 1 is defective. That means probability of 1 we need to find. Probability of 1 defective. So the same thing. Excuse me. So in this formula, write in the place of R1, NPQ values substitute, you will get the answer. So write in the place of R1, 5C1, 1 by 5 whole power 1, 4 by 5 whole power 5 minus 1, 4. So you all know that NC1 is N. NC1, that means 6C1, 6, 7C1, 7, 5C1, 5. So 4 power 4 by, here 5 power 1, 5 power 4, 5 power 5. Otherwise if you want you can cancel 1 5, you will get 4 power 4 by 5 power 4. Use calci to get the answers. 4 power 4 by 5 power 4, 0.4096. Coming to the last bit, third bit. Probability of 1 less than X less than 4. That means between 1 and 4, not equal to 1, not equal to 4. Because we don't have equal to. So between 1, 4, we have these probabilities. Probability of 2 and 3. Probability of 2 means writing in the place of R2 in that formula. That is 5C2, 1 by 5 whole square, 4 by 5, 5 minus 2 whole cube. 5C3, 1 by 5 whole cube, 4 by 5 power 5 minus 3 whole square. Okay, you all know how to calculate 5C2. 5C2 is 10. Like this one can calculate 5C2 and 5C3. 5 into 4 by 2 into 1. If you have here 2, write 2 numbers in numerator by decreasing 1 from 5 and multiply. Denominator from 2. So 2 1s are, 2 2s are, you will get 10. 5C3 is 5. If you do like that, you will get. So if you write in the place of 5C2 10, in the place of 5C3 5, and use your calculator to get the answer, you will get the answer 0.256 is the probability. So like this one can easily evaluate binomial distribution problems. The binomial distribution consisting of 5 independent trials, probability of 1 and 2 successes are 0.4096 and 0.2048. Find the parameter P. So this one is different in the previous cases. We have N and P, Q are given in the question itself. Now N is given because 5 independent trials, and probability of 1 and probability of 2 are given. Okay, so now we need to find P of the binomial distribution. So first write what is given. N5, And in binomial we all know that probability of R successes is NCR P power R Q power N minus R. So using this, the given is P of 1, probability of 1 is 0.4096 and probability of 2 is 0.2048. What it means? Probability of 1 means we know R, we know N, we don't know PQ. Simply write PQ as it is. 5C1 P power 1 Q power 5 minus 1 4 equal to 0.4096. Here also 5C2 P square Q cube equal to 0.2048. Now if you divide, 5C1 is 5, we know 5C1 P power 1 Q power 4 by 5C2 P square Q cube equal to 0.4096 by 0.2048. If you cancel these two, you will get 2. If you want, you can use your calculator. 2 you will get. Here you know NC1 is N. NC2 you can use this formula, N into N minus 1 by 2 factorial. 5 into 5 minus 1 by 2, you will get 5C2. 5C2 is 10. So 5C1 is 5. P. We all know that Q equal to 1 minus P because P plus Q is 1 in binomial distribution. So I am writing in the place of Q 1 minus P whole power 4 by 10 into, here you can cancel P, so you may not get P here. P into 1 minus P whole cube equal to 2. 5 1 jar, 5 2 jar. Here also Q cube Q power 4 we can get cancelled, but here I am cancelling. 1 minus P whole cube, 1 minus P you will have in the numerator. So 2P you are having, send that one to that side. 1 minus P equal to this 2P, if you take here 4P. So 1 equal to 4P plus P, 5P equal to 1. So finally, what is P? P equal to 1 by 5, which is 0.2. If you want, you can calculate Q also. Q is 1 minus P, 1 minus 0.2, 0.8. Like this, one can easily evaluate parameter P using binomial distribution. I said how to identify binomial distribution. The problem is in binomial. When we are having binomial, Poisson, normal like that. So binomial distribution we will consider whenever number of trials are finite like this. Very small. Less than 10 or less than 20. If you feel that n is large like 50, 60, 70, above 50 or above 20, if you take that one as large, there we go for next distribution Poisson. Otherwise you will be in binomial. Okay? Any doubts anywhere you may ask. Fit a binomial distribution to the following data. Fitting a binomial distribution to the data means finding expected frequencies. The formula to calculate the expected frequencies for the given frequencies is expected frequency equal to capital N into P of x, for x equal to 0, 1 to so on. Capital N means sigma fi for I equal to 1 to n. If you add total frequencies, you will get capital N. Capital N means in this problem, adding all 28 plus 62 plus 46 plus 10 plus 4. That is capital N. Next we need to find probabilities. Capital N you will get 150 if you add using your calculator. So now after finding capital N, to fit binomial distribution we need to apply this formula. Capital N into P of x. But what is P of x in binomial distribution? We all know P of x in binomial distribution, NCx, P power x, Q power n minus x. So that means we need to find small n, small p, q. Okay, that values we need to find. Whenever x and f is given, we know formula for mean. Mean, when the data is given like that, sigma fx by sigma f for I equal to 1 to n fix. So this formula we know, we learn in statistics, mean formula. So now sigma fx means nothing, 0 into 28 plus 1 into 62 plus 2 into 46 plus 3 into 10 plus 4 into 4 by sigma f value we know, sigma f is 150. Sigma f I written here, 28 plus 62 plus 46 plus 10 plus 4. That value we need to evaluate. If you calculate the numerator value using calc, you will get 200 by 150. So in binomial distribution, we all know that mean is NP. In binomial distribution, mean NP. In binomial, mu equal to NP. That is mean equal to NP. That we know. So using that, NP equal to 200 by 150, you will get 1.33. So now we know n. N is given. N is count how many values we are having. 1, 2, 3, 4, 5. 5. So now 5p equal to 1.33. We need p 1.33 by 5. We need to evaluate n, p, q, all the values. So p value will get 0.266. Similarly, in binomial distribution, we all know that p plus q is 1. From this, what is q? Q is 1 minus p, 1 minus 0.266. You will get 1 minus 0.266, 0.734 will be q value. Now we know all the values, n value, p value, q value, all the values we know. Now we need to fit the binomial distribution using that formula. For that, what we are doing, we are preparing a table like this. X values and probability of x. After finding probability of x, we are finding capital N into p of x value. So here p of x, we all know what is p of x. X values are given 0, 1, 2, 3, 4. This we are evaluating. For 0, what is expected frequency? For 1, 2, 3, 4, we are finding. P of x we know. P of x has formula NCX, P power x, Q power n minus x. So here we know n value is 5, P is 0.266, Q is 0.734. So that values we are using. P of x means NCX. So 5C 0, 0.266 whole power 0, 0.734 whole power 5. Similarly, this will be 5C1, 0.266 whole power 1, 0.734 whole power 5. So 5 minus 1, 4. 5 minus 1, 4. Next, 5C2, 0.266 whole square, 0.734 whole cube. 5 minus 2. 5C3 0.266 whole cube 0.734. 5 minus 3. 5 minus 3 is 2. 5C4 0.266 whole to the power of 4 0.734. 5 minus 4 1. So like that we need to evaluate all the values using calculator. Using calci, if you evaluate, the first one you will get P of 0 0.213. So calculate, that means 5C0 is 1. 5C0 is 1, anything power 0 1, you need to calculate 0.734 whole power 5 value only. Next, 5C15 using that 0.3875. Next, 5C2 P of 2 0.2715. Next, probability of 3 0.0968. 0.0968. Probability of 4 0.0183. Use your calci. 0.0183. Now we all know that capital N is sum of frequency, that is 150. If you multiply every value with 150, what I am saying, 150 into this, 150 into 0.213, 150 into 0.3875, 150 into 0.2715, 150 into 0.0968, 150 into 0.0183. These values using calculator, directly you can type 150 into 0.213, 150 into 0.3875. If you calculate like that, you will get n into p of x. So that values you will get like this, 31.6 after calculating first one. So next one, 57.6. Third one, calculate 150 into 0.2716, 41.6. Next one, calculate 0.0968 into 150. If you calculate, what you will get, 14.521. 5 you can take. 150 into 0.0183, if you calculate, you will get approximately 2.7. They are expected frequencies. Now, finally you need to prepare a table representing given frequency and expected frequency. Given and expected. What I am saying, XF are given. Here you need to write expected frequency that you calculated just now. Expected frequency. So X is 0, 1, 2, 3, 4. So these frequencies are given in the question itself. 28, 62, 46, 10, 4. Now if you write expected frequencies, so approximate it to the nearest value. 31.6 can be written as 32, this one. 57.6 can be written as 58. 41.6 can be written as 42. 14.5 can be written as 14 or 15, your wish. 2.7 can be written as 3. So my suggestion is try to get closer values to actual frequencies. What I am saying, 14.5 can be written as 15 or 14, but write 14 only. If you write 14, then the difference between actual frequency 10 and 14 will be a little less compared to 15. So try to approximate to actual so that the expected frequencies are very closer to actual. Then the fitting binomial distribution will be over. So you need to calculate expected frequency whenever if you want to fit a distribution. Here we fit binomial distribution. For fitting binomial distribution, we need binomial distribution parameters NPQ. To find NPQ, first fitting means this one we need to do capital N into P of X. Capital N is sum of frequencies 150, these total frequencies. Now we need to find mean, so that in binomial distribution mean is NP. If you equate mean value to NP, already you know n value, number of values given, you can get P. That's why I am finding mean. Whenever except are given, this is formula to find mean. Sigma fx by sigma f. Using that we calculated mean is 1.33. From that, by substituting n value 5, you got P and Q. So after getting PQ, prepare this table. Using that table, we can finalize what are the expected frequencies for the given distribution. Fitting means finding expected frequencies for the given frequencies.